All right, I'm back. Let's talk about page 2 of the final exam review. And I wasn't able to fit everything from page 2 on the board here, so I'm going to have to erase at some point and do the other 2 parts. But here's number 6 and one part of number 7. So number 6 first. Okay, so number 6 is about using the segment addition postulate to find the lengths of segments within a segment. So part A, we've got the segment PR, which has a length of 21. And we know that this piece of it is 12, and this piece we have to figure out the length of. Well, I think we can figure out that if I take the whole length, which is 21, and I subtract this piece of it, which is 12, that's going to give me the length of the remaining piece. So 21 minus 12, last time I checked, was 9. And so PQ equals 9. Okay. Similar situation for part B. We need to find the length of the segment LM. The whole thing, the whole segment from L to N has a length of x plus 4. So let's set up this equation. I've got x plus 4 equals 2x minus 7 plus 3. Okay, so just this plus this equals the whole thing. And now I just have to, do a little algebra and solve for x. So if I do that, how should I do that? I'll subtract x from both sides. How about that? And that's going to give me 4 equals x. Okay, right? 2x minus x is x. And then over here I've got negative 7 and positive 3, so that's going to give me, right. So after kind of the first step of simplifying this equation, I've got 4 equals x minus 4. Okay. All right, and then to solve that for x, just add 4 to both sides. Got x equals 8, and now I'm tempted to just stop right there because I've solved for x, but don't forget, we're actually trying to find the length of the segment LM. So x is just part of the deal. I've got to now take this x, plug it in here, 2x minus 7, in other words, 2 times 8 minus 7 is 16 minus 7, and 16 minus 7 equals 9. So LM is equal to 9, just like PQ was. What a coincidence, right? So that is a wrap for question number 6, okay? Question number 7, I'm going to erase this to make room for the next one, but question number 7, I think this is some angle addition postulate stuff, if I'm not mistaken. Let's see, so we've got this kind of this diagram with a bunch of angles. It gives us some information. It says the ray OB bisects the angle AOC. Okay, so that means, just to kind of use that information to add it to my picture, it means these two angles must be the same measure. Okay, since OB is an angle bisector. OD is perpendicular to OB, so okay, since OD is perpendicular to OB, I know that's making a right angle there. And the last thing is the measure of angle DOC is 70 degrees, so DOC is something here, and that's just that's 70 degrees. All right. I can actually fill in the rest of this. I don't even know what these are going to ask, but I can see what's going to happen here. Since that's a 90-degree angle, and this piece of it is 70, then the remaining bit, BOC, must be equal to 20. And if BOC is equal to 20, then AOB is also equal to 20, since, as we said before, those two angles are congruent. All right. So I think now I have everything I need to just answer these four things here. So what is the measure of angle DOB? Well, where is DOB? DOB is boom, boom, boom. We already know that that's a 90-degree angle because it told us right here that those two rays are perpendicular. Great. COB. COB, well, again, we kind of already did the work here, but COB is 20 degrees. Because we just kind of applied the angle addition postulate there. 90 minus 70 is equal to 20. BOA, those two angles are congruent. So since COB is 20, then BOA is also 20. And last but not least, the measure of angle AOD. AOD is all three of these angles added together, which 70 plus 20 is 90, 90 plus 20 is 110 degrees. Okay, so that is a wrap for question number 7. Oh, question 7A. This is just 7A. Okay. 7B gives a diagram that looks like this. Kind of like this. That's K. That's L. That's M. And that's C. And then I'm just going to read off this information that's given to you here, but it says KLC, the measure of KLC is 32 degrees. KLM, which is this whole thing, is equal to 25x plus 2. So that's for like the whole thing, right? And CLM is 19x plus 6. CLM, 19x plus 6. So there's kind of a lot going on in this diagram. So let's kind of try to be careful and make sure we keep track of everything the right way. All we need to figure out is the measure of angle KLM, which means we have to figure out the value for x, right? Let's see. So I think I know what we need to do. We need to set up an equation, right? Because we know that the measure of angle KLM is equal to the measure of angle KLC plus the measure of angle CLM, right? So I know that kind of looks like a bit of a mess here, but all this equation says is KLM is equal to CLM plus KLC, okay? And I've got expressions for each of those. KLM is 25x plus 2. KLC is 32. And CLM is 19x plus 6, right? So now we're getting somewhere. I just need to solve this for x and then plug it back in to get the measure of angle KLM. So if I subtract 19x from both sides, that seems like the move. 6x plus 2 equals 32 plus 6 is 38, right? Subtract 2 from both sides here, and I get x equals 36. Okay, and again, just like before, wait, no, x is not 36. X is 6. 36 divided by 6 is 6, so x is equal to 6. Now, I'm going to take that value for x, plug it back into this, get the measure of angle KLM equals, let's see, 6 times 25 is 150. 150 plus 2 is 152 degrees. Okay, fantastic. All right, one more to do on page 2. Now 7B. Okay, what's 7B about? Okay, yeah, I know this one. This is 7C rather. 7B. Here's 7C. What's the deal here? So I've got a line. This line is named B. And here's point C. It kind of does this. It kind of does this. There's A. There's D. And then 3, 2, 1. Those are the names of the angles in there. Great. And what do we need to do? Well, again, it gives us some information. So actually, let's look at that first. It says the ray CD, which is right here, bisects angle ACB. Boom, boom, boom. So this angle, angle 1, then must be congruent to angle 2. Okay. The measure of angle 1 is 5x plus 2. Interesting. So it gives us that. If that's 5x plus 2, oh, and it says angle 2 is equal to 3x plus 10. Okay. So we've got those, and I know those are equal, so I think I can use that to get a value for x. Oh, and then that's what we need to do. We need to find x and then find the measure of angle 3. So since these two angles are congruent, I know 3x plus 10 equals 5x plus 2. Subtract 3x from both sides. 10 equals 2x plus 2. Subtract 2 from both sides, right? Just making sure. Yes. So that is an 8 equals 2x, and x equals 4. Cool. We got x equals 4. If x equals 4, how's that going to help me find the measure of angle 3? Well, let's see. If x equals 4, I can plug that into either of these, and that should give me the measure of the angles, right? They're both the same. So if I plug in 4 equals x, I'm going to get 12 plus 10. This angle is 22 degrees, and so is this one. Okay? Those are each 22 degrees. What's left over from this 180 degree angle, this is a line right here. I take 180 minus 44, because 22 and 22 is 44. That will give me what's left over for the measure of angle 3. So 180 minus 44 is 136. Measure of angle 3 is 136 degrees. Okay, so we're doing good. That's page 2, page 3, and the rest are coming up in a bit. Cheers.